So today we're just looking at some of these same problems as yesterday, but have a little bit more focus on these two right here. So you're going to be doing the fraction exponents and some negative exponents, also combined with the other ones, but this one is the one that you really want to focus on and making sure that you know the root here part is what goes on the bottom and you don't accidentally switch those, little things like that. So just do a few examples and you guys have plenty of time to work in class and get used to this. Let's see here. So first of all, you usually want to simplify the numerators and denominators separately before combining them. So something like this. Since you have two terms on top, you'd want to combine those together first. Add those up. Remember, you're just counting how many there are really. There's 5 here and 7 here. You're just adding them up. 5 plus 7. And then we got the bottom. And then finally, we can use the second rule for division here and subtract these exponents. So we can have w to the a plus b. And then from there, you would subtract what c is. So the goal here is stated in the directions. You want a single term, right? So we have multiple bases. We want to combine them all into one. And you want to simplify the exponent as much as possible. So if it's a fraction, simplify the fraction as much as possible. Also, if you have a fraction exponent as your answer, if possible, you're going to write it back into this format. So the problems you're going to do for homework are from the book. So you could check the odd number answers in the back to make sure you're just writing in the correct format. There might be an equivalent format, but we want to go as close to the book as possible. And if it doesn't match, we can play with why it's not finished. Okay? So something like this, as you can see, will be a fraction. So the first thing you want to do before you combine these bases is make one of them a fraction. This v by itself will just be v to the 1. So then we got v to the c over a. Right? And from there, you can combine it to be v to the 1 plus c over a. And this, since we got two parts here, they can be combined. You want to keep on going, so you have to do a little algebra and combine those together. And if you can combine these, if you can just go like, okay, that's going to be a plus c over a, that's fine with me. But if you're looking at that and you're like, I'm not sure how to get that, then you still need to write out the work and write out the common denominators. That's fine too. So 1 is the same as a divided by a. That's what 1 is. And then you got your a plus c on the top with your common denominator of a on the bottom. So that's how you get that. But at some point, if you do these enough and you do fraction work enough, you could just go from here to here. It's assumed that you know how that works by now. This is a problem from the 5th or 6th grade. So if you're used to it, don't bother showing this. If you need to see this part to get that, then keep doing it because you want accuracy over speed. So this is going to be a lot of the work that you might have to think about during this assignment. It's just combining fractions that have a lot of variables in them. Okay, so go ahead and try number 1 over here. Try number 1. Combine these all together to have one base and combine the exponents together so it's just one single term. So we should have c to the xy minus 1 over y. Okay. So if you went straight there and you got that, good job. If not, just go over here and show the work. Write it out. So we need a common denominator of y. So I have to multiply this one by y over y. So that's why I have xy minus 1 on top. And the common denominator y on the bottom. So it's just a little extra to write out to get this correct. And then after doing this enough, you might find, don't really need that. Or you might be like, I'm just going to do this every time just to be sure. I mean, it is an extra 2 seconds of writing, so if you have any doubt whatsoever, just write it out, right? And you'll be okay. So, and keep in mind, it's just 5th, 6th grade rules. Don't overthink it. Don't try to make it more difficult than it needs to be. It's just common denominators, adding, subtracting. All right, so there you go. So next we'll have some problems with just numbers in them, right? Now these are nice because you could actually put this in the calculator. It's going to be some irrational decimal, and then you take your answer, put it in the calculator. It should be the same exact irrational decimal that goes on forever, right? So you can double check these pretty easily. On some of these, it's going to be straightforward. On these, like, maybe you can catch this and see, like, well, 2 to the 3. Well, 16 can be written as 2 to the 4th. So these are going to be solved separately from these, where they're the base of root 5. So what you have here is really two different problems just kind of stuck together, but you solve them independently. You're never going to, like, this root 5 is never going to interact with 2 to the 3rd because this is a root 5 base, this is a 2 base. So there's nothing we can do if they're different bases. Only the same base can we actually simplify with. So this one, 16 is 2 to the 4th. So 2 to the 4th to the 2nd would be 2 to the 8th, divided by 2 to the 3rd, right? Which is just 2 to the 5th. And the rule was, if whether or not to multiply this out, well, if the answer is less than 1,000, multiply it out. So 2 to the 5th is definitely less than 1,000. It's only 32. If it was 2 to the 15th, I'd leave it as 2 to the 15th. But it's 2 to the 5th. So that's half of the problem, and then you could do the other half over here, which is completely separate. They're just stuck together. So here we have, this is a square root. If there's no number there, it's automatically a square root. So this is 5 to the half power, while the bottom would be 5 to the 3rd power. And just like the red here, we did 8 minus 3 and got 5, so we can do 1/2 minus 1/3, which is a 6th. And we generally don't want to leave our answer with a fractional answer, or a fractional exponent. So if you have a fractional exponent, convert it back to the square root format. So here we'll have the 6th root of 5. And that would be the final answer. 32, 6th root of 5. So if you put the question in the calculator, get the decimal, and you put this in the calculator, get a decimal, it should be the same exact decimal. They're equivalent to each other. Hence the equal sign. Okay. Now you don't have a calculator during the test. This is just for, making sure you're doing it correctly and learning it properly. So by the end, and by the time you're taking a quiz or test, right, you will not have that. Just have to be confident in your work. All right, so that's a good one. Let's see here. B, so we have square root of 2 times the square root of 32. Just like over here, recognizing that 16 is a power of 2, you want to recognize 32 is a power of 2. It's 16 times 2, so this must be 2 to the 5th power? This must be 2 to the 5th power. That changes everything. Now, if this was square root of 33 or square root of 34, I couldn't write that as a power of 2. This would not be happening. So all these problems will depend on them having the same base, so you can kind of expect that to happen and look for it. Right? Not that it happens always, but on these problems it will. So we have, once again, like over here, the square root is a root of 2, right? So this is a root of 2. So this whole part I can rewrite as a fractional exponent, right? That'll be 32. Nope. That'll be 32. No, 2 as the base. We have the 5 on top, and the over 2 for the square root on the bottom. So the square root of 32 is the same as 2 to the 5 over 2 power. And everything else just comes down. So this 2 right there comes down, and the square root as well. So 2 is the same as 2 to the 1. So now we have 2 to the 1 plus the 5 and the over 2. So with the colors, you can kind of see where, where things are coming from. That 1 came from this 2 from the very beginning, right? That's where that came from. The 5 came from the fact that 32 is 2 to the 5th. And this 2 down here came from the fact that it's a square root. Right? Came from this right here. He is? Yep. Oh yeah, I'm not done. And then we still have the other square root, the original square root to bring down as well. Now, you could change this one and also to a 1/2 power and multiply this whole thing by 1/2, but it's kind of easier to simplify this first and then do it one more time, just so you don't have too much going on at one time. So let's do this. What is 1 plus 5 over 2? We get 7 over 2. Yeah. And then we could take the square root. Okay. So same rules, right? It's just that we're going to use this right here. Right, the a is right here. So the a is 7 over 2. So it's going to be 7 over 2 divided by the root over here. So it's going to be 7 over 2 divided by 2. So now we have 2 to the 7 over 2 divided by 2. And now there's no more radicals. So what is 7 over 2 divided by 2? 7 fourths, 7 over 4. And then just like this one over here, we wouldn't leave it as just a power to a fraction, 5 to the 1/6, rewrite it as the radical form. So this will become, what is that, 2 to the 7th, the 4th root. So the 4th root of 2 to the 7. And 2 to the 7 is less than 1,000, so one more step. Figure out what 2 to the 7th actually is. And in this case, it's, let's see, 6, 64, it'd be 128. 4th root of 128, when it's all said and done. All right. Good. So those are the number problems. These are checkable. You can put the question in, put the answer in. Should be the same exact decimal, just so you get some confidence as you're going along that you're getting them right. Now, if your answer doesn't match perfectly in the back of the book, check the decimal of the answer in the back of the book. You might have another equivalent way of writing it. Okay, so your way might be correct, and there's other correct ways, so that's just one of those things as you get further in math. There are multiple ways to represent numbers that are both equally correct. Okay, so it doesn't have to be an exact match, but you can always check by decimals. Only if there are problems with all numbers, obviously. Okay. So that's the main focus of everything you're doing today. Practicing these fractional powers, combining, terms and whatnot, using common denominators, and then doing these simplifying terms. Sometimes there's 2 problems wrapped in one. You just do them separately, but you can have the answers for each problem together, like we did here, right? Just 2 different problems combined. And the next part is looking at the reversing of the exponential. This is a setup for logarithms, right? So when your variable is in an exponent, that's when logarithms come in. Obviously here, like what power of 7 is 49, right? We know 7 to the 2nd power is 49. So we don't need logarithms. But if this was 48, well, 7 to what power is 48? It's not going to be an integer and a nice number anymore, and that's what you use logarithms for. So this little exercise just getting you ready for that. Okay? So this one, what power of 3 equals 9? And you'd say 2. 3 to the 2nd power is 9. How about what power of 5 is 125? 3. Good. So those are the straightforward ones that where they're nice positive integers. What about here? What power of 2 equals 1/4? We got -2, right? So you notice that if I'm going from an integer, positive integer here, to a fraction, the only way to do that be using this up here to have a negative exponent as an answer. So these are the patterns that you want to keep track of and think about, because the first two are pretty intuitive because you've been doing these, positive powers for, since the 7th grade, maybe earlier, right? Whereas this is not as new. So realizing you can get fractions, and this is a weird thing to comprehend sometimes, that a fraction is a negative exponent. So it's maybe not intuitive, like, well, how do I get from 2 to 1/4? Oh, yes, it's a negative number, right? Not quite as obvious. Same thing over here. How do I get from 25 to 5? What power of 25 gives you 5? Right? So how do I get from, what do I have to add to the 25 to make this true? What else would I include this? How do you get from 25 to 5? What would you do to 25 to get 5? Square root, which is what power? 1/2. That's another one that's not quite intuitive. So when I have a big number and I'm taking it down to a small number, often that means the answer, the exponent, is a fraction. So these two, 5 and 6, are the ones that you really want to, be thinking about, because it's not quite as intuitive, right? And I'm going to throw in one more problem. That is this: what power? Let's say negative 3, and how about negative 27? So what power of 3 gets you to negative 27? All right, so you remember, if you look at your homework, what about those graphs that you did? Where do the graphs of all those problems live? Positive, right? Negative 27 is way down here. So there's no way to raise a positive number, right, to any power and get a negative answer. So this has no solution. I should throw in, some of you probably caught this, no real solution. So if we start getting into, well, I could raise 3 to the I power, and that might give me 27. You're on the right track. It's not I, but there is a way to do it when you're talking about the complex. But we're sitting in the real numbers only right now, so for now we say no real solution, or no real number solution. Okay. So if these 3 make sense, that's usually where the problems exist, where the mistakes are made because it's not quite intuitive, right? So think about that. If you're going from positive number to fraction answer, that's a negative answer. If you're going from a bigger number positive to a smaller number positive, the exponent is usually a fraction. You have to take a square root, a third root, a fourth root, or something like that. All right, so your homework, I think this is number 33. So write this on the top line of your paper, and you could do the A through D down below, either at the beginning of the assignment or at the end of the assignment, but do it on this paper. Don't do it on the notes. So you copy those down on paper, and then so you have the entire assignment, all the problems, on one sheet of paper. Okay. And you got lots of time to work and ask questions. Check the back of the book for the odds as you go, just to make sure you're doing them correctly. And